Hello everyone, welcome to my channel. In this video we are going to learn about the one of the classic IPC problem, bounded buffer problem. So in the bounded buffer problem, so we are having the pool of n buffers here available. Okay, and each buffer can hold only one item. Okay, so when all the buffers are full, then the producer will wait and the consumer will wait when the buffers are empty, right? So here there are producer and consumer, right? So here there is a producer P and consumer. Okay, suppose I am taking only one buffer. Okay, so a producer will produce a item in the buffer. Okay, so when there is something in buffer only, then the consumer can consume it, right? So if the buffer is empty, then the consumer cannot consume anything, right? Similarly here, the producer can produce a item in the buffer if and only if the buffer is empty, right? So here the producer and consumer must be synchronized here. Okay, so producer can produce the item in the buffer and the consumer will consume the item from the buffer. So producer can produce only if the buffer is empty. Okay, so that's why the producer will check the semaphore empty here, and similarly the consumer will consume the item from the buffer. So if it is full only it can consume, so that's why it will check the semaphore full. Okay, so to properly synchronize these two, producer and consumer, so we are going to maintain a semaphore or synchronization between the producer and consumer, that is the mutex here. Okay, so that's why we're having three semaphores here, so full, empty and mutex. So here both the producer and consumer should not access the buffer simultaneously. That means so both the producer and consumer cannot simultaneously access the buffer. So it cannot produce and consume the data at a time. Okay. So we can consider here we are having the pool of n buffers. So n means it may be from 1 to infinity. Okay. So here we are going to check the code of the producer and consumer. So here in the producer, so it is going to produce an item in the next to P. So next to P means we can consider it as a pointer here for the producer. So it is ready to produce an item. So weight of empty. So initially we are going to consider the full value as, so here, so we are going to consider the full f equals to 0 and empty equals to n and mutex value equals to 1. So we know that so producer is going to check the empty semaphore, whereas the consumer is going to check the full semaphore. Okay, so consumer can consume an item only if the semaphore f is 1. Okay, similarly if the semaphore empty is, so so that's why here the initial values are f equals to 0, empty equals to n and m equals to 1. So n means denotes the number of buffers between the producer and consumer. So here weight of empty, that means so we are going to perform the weight operation, that means decrement the empty operation by 1. Okay, so I am taking the empty, so number of buffers here as 2. Okay, so we are considering here number of buffers as 2. Okay, so at that time, so here the producer is having the number of buffers as 2 and the consumer here. Okay, so here the producer will produce an item in the, so weight of empty, that means it is going to decrement by 1. That means the empty value will, so here initially the empty 2 buffers are empty, so the producer is going to produce the item to the buffer, so that's why it is decrementing the empty value by 1. And weight of mutex, so that means we are going to occupy the buffers, right? So that's why it is going to decrement the value by 1. And the critical section is occupied by the producer and it will produce the item in the buffer. Okay. Next, after coming out of the semaphore, it is going to signal of mutex. Signal means it is going to increment the value. So it is going to increment the m value by 1. And signal of full. Okay, signal of full means it is going to increment the value by 1. So now there is the end of the while loop. So if you check, there is only one buffer is full and one buffer is empty here, right? And the mutex value is again 1. Okay, so now, so if we execute the same code for another item producing, okay, to produce another item, we are going to execute this same code again. Okay, so produce an item p in the next pointer. Okay, that means producer is ready to produce the item. Okay, so next, so wait of empty. So it is going to perform the wait operation on empty. That means it will become 0. Okay, so empty will become 0. Okay, so now, so wait of mutex, that means it is going to decrement the m value by 1. It will become 0. Okay, now it is going to enter the critical section and the producer will produce an item in the buffer, that is 2. So it is going to produce the item 2 in the buffer. Okay, and after coming out of the critical section, the producer is going to increment the mutex value, right? That is 1. And then signal of full, that means it is going to increment the full. So the full f equals to 2. So at the end of the running this code, the producer, so here the full value is 2. That means 2 buffers are full. So none of the buffer is empty and the mutex value is again 1. So this is how producer will produce an item. So next, coming to the code of the consumer. So consumer means it is going to consume the data, and consumer will always check the whether the f buffer, that is the semaphore full is at least it must be 1, then only it can consume the item, right? So that's why it is going to check the wait of full. Similarly, if you take in the producer, it is going to check the semaphore empty first, right? So since it depends on the empty semaphore, because if the buffer is empty only it can produce, right? So here in the consumer process, it is going to check the semaphore full. Okay, so if the semaphore full value must be at least 1. Okay, so now we are going to apply the same code for the previous example here. Okay, so here the producer is having the have produced 2 items here, 1 and 2, and the consumer here, it's ready. So let us take the values here. F equals to 2, E equals to 0, E equals to 0, and M equals to 1. Operation, that means, so we are going to decrement the value by 1, right? And then is going to enter the critical section. So it will make the value as 0 and it is locking the critical section. Now remove an item from the buffer to next C. That means it is going to remove the value from the buffer and it is placed in the pointer of the consumer. Okay. So next, signal of mutex. That means it is going to increment the value by 1. And then signal of empty. Okay, signal of empty. So it will increment the value by 1 of the empty semaphore. Okay, so now, so it has the consumer will consume the item which is in the next C pointer. So it is going to consume the data here. So now that too is consumed by the consumer. Okay, so next, so it will consume the item in next C. So now while of 1, that means the do while is true. So now for the next, so next again to consume the next item in the buffer, so again we have to execute the same code. So wait of full. So here we are having the f value as 1, empty as 1, and the mutual exclusion value is 1. So here the full is 1, empty is 1, right? So the consumer has now consumed the first item, right? First of all, okay. So first it has consumed the one item and then it will consume the two. So weight of full. So weight of mutex. So weight of full means decrement the value by 1, and weight of mutex. So it is going to decrement the value of m as 0. Okay. Now the consumer is ready to enter the critical section, and it will remove the item from the C. The next C, that is a pointer. It is going to consume the data from buffer to the next C pointer. It is going to maintain the data in the pointer of the consumer. Okay, and then it is going to signal of mutex. That means it is going to increment the value of m by 1 and signal of empty. So it is going to increment the value of 1 by for the empty. Okay, so now it will consume the item in the next cell, that is in the pointer. Okay, it will consume the data, and then that is the end of the while loop. So now if you check, so f equals to 0, that is full value is 0 and empty is 2. So two buffers are empty, and m value is again initialized to 1. Now the consumer cannot consume the item since the buffers are empty here. Okay, so like this we are going to execute the bounded buffer problem for n number of buffers. Okay, and here it can consume the data in the order of FIFO policy. Okay, the first produced item will be consumed first. So this is about the bounded buffer problem. Thanks for watching my video. Thank you.